right, so this is a goal. We're to verify the following. So the task is verify the given identities. All right, so let's say you have you're asked to prove, number one, that sine to the fourth x is equal to sine square x times 1 minus cosine square x. Now the strategy here is you want to use whatever the look of the identities that are given to determine which identity you want to use, okay? Now what you notice on the right side is that you have a square and a square. So what kind of identity will you want to use in this case? Pythagorean identities, right? So we're going to use this one right here. This one has sine and cosine, so we are going to use this identity to make a substitution. If you look on the left side, there's only sine, so if you can get rid of cosine, that would be great. From this identity, if I solve explicitly for cosine, I will have 1 minus sine. Now if I solve explicitly for sine, well, let me solve for cosine first. That doesn't help. If I solve for sine, sine squared theta is going to be 1 minus cosine squared theta. Okay, subtracting cosine from both sides. Now I can rewrite this as sine to the fourth x is it equal to sine squared x times what? I want to substitute 1 minus cosine squared theta for x with what? So replace it with sine squared x, because x is a variable in this problem, so we have sine square x. Now we're going to use the product property of exponents. Whenever you're multiplying exponents of the same base, what do you do with the powers? You add the powers, right? So it's going to be sine to the 2 plus 2 plus 2x. Okay? You add the powers, and then you have sine to the fourth x. Is it equal to sine x raised to the fourth power? Are they the same? Are they the same? Yes, they are. So we have verified that the identity is in fact correct. Verify number 2. Verify that if sine square x is equal to 1 minus cosine square x. To verify is to make sure if we can make the left and the right hand sides the same. This one is straightforward. Okay, let's pause for a second. Let's show that sine square x plus 2 is equal to 3 minus cosine square x. Much better. All right, so in this situation right here, we're going to be using the Pythagorean identity because you have squares there. Now let's take a look at the Pythagorean identities real quick. We have, let's see, what do we have? Sine squared theta plus cosine squared theta equals 1, right? From this one, I know that sine squared theta is equal to 1 minus cosine squared theta, right? So let's see, what if we subtract 2 from both sides of the equation? Let's try that. Subtract 2, subtract 2. Why did I subtract 2? On the left side, we have sine squared theta, or x, and then 3 minus 2 is 1 minus cosine squared x. Okay, now using this identity right here, What is the last substitution that I can make? All right, so let's do exactly what Victoria said. So we're going to rewrite this as sine square x. Replace 1 minus cosine square x with its equivalent sine square x. Both of them are the same. We have proved that the identity is true. What if you're asked to verify that 1 minus secant x times 1 plus secant x is equal to tan x, tan square x. Okay. Now we have a square here. Whenever you see squares, you think, can I use the Pythagorean identity? When you see two quantities multiply by each other, you think to multiply out and see what happens. Okay? So this is a difference of squares, a plus b times a minus b. What is a plus b times a minus b? I'm sorry, yeah, a plus b times a minus b. What is that equal to? A plus b times a minus b is an expanded form of a difference of squares. It's a squared minus b squared. So here is as though you have a minus b times a plus b. Okay? So let's write down a squared minus b squared. So let's do it the long way, and then you see why she's correct. Okay? So let's just FOIL it out. Let's act as though we don't know the shortcut. So we're just going to FOIL this out completely so that you guys see exactly what's going on. So first, outer, inner, and then last, okay? So 1 times 1 is 1. 1 times secant x is positive secant x. Negative secant x times 1 is negative secant x. Negative secant x times positive secant x is negative secant square x. Anytime you expand or FOIL out difference of squares, what always happens to the middle term? They cancel out. So we end up with what Ileana said, a squared is 1 squared, which is 1, minus b squared, b is secant, which is secant square x, equals tan square x. We do not know yet if this is true. Okay? Questions at this time? Alright, so the identity we're going to use is, what is it? Tan square x, or theta, plus, oh boy, I wrote it as 1 plus tan squared theta, right? Equals secant. That's the format in the formula sheet, so I want to stick to that format so we don't get confused. What if I get tan by itself here? If I get tan by itself, tan squared by itself, that's going to be 1, actually it's going to be secant squared theta minus 1. Secant squared theta minus 1. Okay? Alright, so let me see. We need to make an adjustment here so this works. There should be a minus here. So put in a minus next to the tan so that this problem works out. Okay, so we have secant squared theta minus 1. And in order to make this side equal to this side, we have to switch the order of this. Okay, 1 minus secant squared theta. So 1 minus secant squared theta, anytime you switch minuses, so let me switch this around, it's going to become minus secant squared theta, secant squared x, minus 1. Anytime you switch it, a minus comes out. Okay? Is that equal to negative tan squared x? Alright? Now we can make a substitution. That's why I tossed that minus there. Secant squared x is equal to tan squared x. So I can replace this whole situation right here with tan squared x. Okay? So we have negative tan squared x. Is it equal to negative tan squared x? And the answer is yes. Alright, so let's put a minus here. So let's put a minus. Left it out. Okay, so that's that. So bottom line is whenever you have parentheses, quantities multiplied by each other, you want to FOIL it out and then use the Pythagorean theorem to make an equality happen. So let's say we have, to show that cotangent x times secant square x minus 1 is equal to 1. Okay, cotangent square. Now, if you take a look, there are two ways you can do this. I can write it as sine and cosine, or I can use the Pythagorean identity. Both ways will work. But the fastest way is to use your Pythagorean identities here, okay? So which identity are we going to use in this particular problem? So check this out. Let's say we have this identity again, 1 plus tan squared x equals secant square x. If I subtract 1 from both sides, I get tan square x equals what? Secant square x minus 1, right? Is that true? Yeah, so I can now make a substitution. Cotangent square x times tan square x, is it equal to 1? Is it? Now I'm at a roadblock. How do I advance? So we write cotangent as 1 over tan. So we have 1 over tan square x times tan square x. Is it equal to 1? Is it? Is it? Absolutely. This divides out. And then you have 1 equals, is 1 equal to 1? It certainly is. Okay? So that's that.